Hello, virtual class. I'm Miss Porter,
I'm Miss Stilfen.
and we are creating something new here. Our purpose in doing this is to help out people who were absent from class and didn't get a chance to do this procedure, and for people who maybe are a little rusty and could benefit from review. We are making this movie for you.
So appreciate it. Okay.
And what is our recipe today, Ms.
Our
Stilfen?
recipe today, first part we need to do is prepare 3 cups, 1 level spoon or a 5 ml spoon of each solid material in its cup. And then we're going to observe the 3 solid materials and fill in a property chart.
Now, I read the title. It says separating mixtures. So, what is a mixture, Ms. Stilfen?
A mixture is 2 or more things that are combined together, not necessarily, well, you can separate them, but depending on what you need to do, it might be harder than other things, and we'll explore that a little further.
Now, part 1, we're not actually making a mixture yet.
No.
We're just looking at the properties of gravel, powder, and salt.
Exactly.
And a reminder that a property is anything you can notice or observe about a substance. So we're going to do some close observation of the color, texture, particle shape, particle size, and anything else we can about gravel, powder, and salt.
Exactly. And the powder is actually something called diatomaceous earth.
Really?
Yes, yes, and that is the remains of some skeletons of some sea creatures from long ago. So for those of you that thought that was pretty interesting.
When I was in Scotland, they used the term wee beasties to talk about little creatures. So these are
Wee beasties?
wee sea beasties, aren't they?
They are. All right.
So we're putting the 3 materials on a background of black construction paper because we think that's going to help us look at the properties
Yeah.
more easily because the black background will make things stand out.
Yeah, easy for you to view. So hold on, you might get a little motion sick.
Gravel. So I'm looking at the gravel and I notice that not everything is the same color. I see gray, tan, I see a little bit of kind of shiny mica.
Maybe some pink in there too.
Yeah. So there's no one color to describe gravel. Its texture, I'm going to put my hand in there. Ow. It is very hard and rough and pointy. It hurts when I roll it between my fingers. If you were going to describe the shape, Miss Stilfen, of gravel, what would you say?
I see some shapes are kind of rounded. I see some others that are more triangular, even some maybe even rectangular shapes in here. There are so many different shapes. I wouldn't just say just one.
I found myself wanting to say that they have an irregular shape,
Oh,
meaning
yeah.
nothing you can really predict. Each one's a slightly different shape than the other. So that might be an important property to note because it could be useful later on.
Definitely. All right, what about size?
Again, this is the interesting thing about gravel. There's no piece of gravel that's
Yeah.
exactly the same size as another.
I mean, that one is a lot bigger than like one of those over there.
So I find that when I'm talking about size, rather than saying something is big or small, that's not really useful for scientists. It's more useful to compare it to the size of something that we all know. And I've heard a lot of students in class say that gravel size kind of reminds them about the size of, is it nerds or runts?
Oh
It's
yeah,
one of
nerds,
those
yeah.
Nerds, those little
definitely.
candies, nerds, that the gravel's about that size. And one useful description could be it's definitely bigger than the size of your pencil tip, but smaller than the size of your pencil eraser.
Yeah.
Anything else that you think is worth noting besides the fact that it looks like there's some very powdery pieces of gravel
Substance
in there.
Well, let's see.
Well, does it bounce? Huh.
Guess not.
When you're exploring properties, you're trying to find out as many different things about an object as you can. So if we had a bigger lab and more complicated instruments, we could choose to weigh gravel. We might see if it is combustible. Can we set it on fire? What else could we do?
Well, we could probably even get a really fine-tuned measuring instrument to actually measure some sizes of it versus just comparing for what we know, like nerds. We could probably even use a magnet to see if it has magnetic property.
Excellent. All right. Well, that's about all I'm noticing about gravel for our work here.
All right, let's move on to the next one.
Powder. Now I'm going to give that powder a little shake before I put it down so we can watch it spread out. Color.
Wow.
It's pretty obvious.
Yes, I would
Right.
say white.
White, white, and white. Texture. Oh, very soft, very fine texture. I can't feel like one particular piece of powder on my fingers, although it does tend to stick to my fingers. It's pretty fluffy, and it feels a lot like the flour that I use when I'm baking.
Yep.
I certainly wouldn't use this for baking,
No.
but it reminds me of the texture of flour.
Almost reminds me of like baby powder too. If you've ever played with some baby powder.
It's very dry.
Yes. And I can't see any one individual grain of it. I mean, they're very, very tiny.
So I can't even tell you the shape of it because I can't
Yeah.
see one particle piece.
Exactly.
And so size too is really difficult to describe because it's so small, but I can't say small and be scientific. So I would say that it is smaller than a grain of sand.
Oh,
That gives
definitely.
people a sense of how tiny it really is. Smaller than
I had
a
one of my-
snowflake.
Exactly. I had one of my students also observe they're almost like microscopic. Like you'd have to have a microscope to really see one individual grain and what it looks like.
So they're too small to see without the
Yeah.
help of a tool.
Exactly.
That's pretty important. Anything else? Well, I'm noticing that I can really tamp this down.
Yeah. And it keeps the shape.
Yeah. So it really does remind me of flour that I would use for baking bread. All right.
All right.
That's it for
Guess
powder.
we'll move on to salt or kosher salt. Now this, you guys have probably all seen before. Who has never not spilt some salt somewhere or got it spread all over the table?
It makes noise when you
does.
push
When
it
you
on
touch
the.
it.
Yeah, I'm noticing that.
And it feels rough.
Does it feel like sand at the beach?
Yes,
Yeah?
most definitely.
Yeah. Although I was able to kind of break it up into smaller pieces when I
Yeah.
rubbed it, but it does have that pointy, sharp feel of
Yes.
sand at the beach. And I can see pieces of it without a magnifying glass.
Yeah. And some pieces are definitely bigger than others. Like
Oh,
there
yeah.
are some bigger pieces, and then there are some really tiny ones too. Like there's a big chunk right there.
So I wonder if we can break it. I didn't try to break the powder because
Yeah.
it was so small I wouldn't see it, but
I think you are breaking some of it up.
yeah. So it is fragile enough that we can break it up.
Yeah.
That's
Ooh.
good to know.
What would you say about color though?
Well, this is a tough one because when it's in a pile, it looks white, but then when I see individual pieces, they almost look clear.
Yeah, kind of like a what I call an opaque color.
Ooh, nice word.
Yeah, you can kind of see through it, but it's not a solid white like that piece there.
All right. So, a spoonful of each of these materials. You know, something else I noticed, Miss Stilfen, I'm going to put
Sure.
them near each other.
Yeah.
I noticed they take up space differently. I don't know what to do with that. That probably goes in the other, but the powder seems to kind of stick together and the gravel doesn't.
No, it
I mean,
does,
when
kinda rolls
yeah,
over.
can you hear that?
Sounds like a rattle.
Yeah, so even seeing if they make noise, the powder, ooh, I spilled some. The powder does not make any noise.
At all.
And the gravel does,
And the salt does as well.
and the salt does as well. I don't know if that'll help us in our investigation, but anything we can find out about a material helps us understand
That's
it
right.
better.
Those are some great properties that we noticed.
So I'm thinking we need to
Move on to part two.
part two. What does it say for part two, Miss Stilton?
Part 2, it says add 50 mLs of water. This way.
A full syringe to each cup.
Cup. Stir and observe, and then write your observations.
So first challenge is to get the gravel. Now, I want people to notice that I have labeled
Yes.
my cups, because why would we want to confuse ourselves with what is what if we could label it and stop the confusion? So G for gravel, P for powder, and S for salt. The salt's pretty easy to pour, and so is
Yeah.
the gravel, I noticed.
Slid right in there.
The powder, ooh, hey, that worked.
Nice.
Should I get this extra, or would that be contaminated?
Well, now that it's been on the lab table, it's probably a little contaminated with gosh only knows what else.
And we have to be careful about contamination in the lab.
Yes.
That's why we don't eat or drink in the
No,
lab.
no food or drink in the labs ever.
So I just happen to have a syringe here, Ms. Stilton.
Wonderful.
And so what do you want to do first? It
Well,
says,
It says you wanted to do the gravel and water first, and I will note that our syringes have what I call like a screw in them to kind of help stop you exactly at 50 mLs, because otherwise I'm sure some people might not measure exactly.
I
So,
love these. I call them foolproof. Not
Yes.
that any of us are fools, but
No.
it takes the guesswork out of it. So we're going to put this in the gravel first.
So right up to the line there. And we're going to slowly add it to the water. Remember, tools, not toys.
I'm noticing,
I think the rocks got darker. Might be a little lighter in color.
Well-
I added some of the water to it.
and the stream of water is kind of causing them to move around a little,
Yeah.
but they stay at the bottom. They didn't float or rise or do anything really interesting.
Other than the getting slightly darker, I don't think that changed much at all.
I wonder if we should bring this up close and personal for people to see. So I'm going to stir, and besides getting wet and looking a little darker and prettier, I don't see anything else happening to the gravel. Do you
Me
notice? No?
No, I don't see anything else changing in it whatsoever.
All right.
So apparently in that case, the water didn't make much of a difference.
So, we're also going to be discussing some terms here that, depending on when you're watching this, these are either new or review.
Exactly.
The word dissolve is something that we started to talk about after this investigation. So if you're watching this as review, you already know that term. I added water, but I haven't stirred yet. What do you notice, Miss Stilton?
Well, I noticed that the water became extremely cloudy. Like I can't see through it anymore.
It looks almost like skim milk
Yes.
to me. So I'm going to stir. You want to bring the camera in a little closer as I'm stirring. Exciting science here, ladies and gentlemen.
That's right.
So, definitely milky looking.
Yeah.
Ooh, I can see the powder swirling
Yeah.
within it.
True.
So this word dissolve means when the pieces of particles get smaller and fit between the spaces in water so that they look like they've disappeared. And when I look at this, nothing is disappearing.
So you said it looks like it disappeared, so you mean it really doesn't disappear?
It does not. It just becomes so small that we can't see the individual pieces anymore.
Now that you stopped stirring a little bit, if I pick this up, do you see almost like a ring
It
towards
looks-
the bottom?
Yeah, it looks like it's piling up at the bottom of the cup kind of like when you make chocolate milk and you stir, but then the chocolate sinks back to the bottom
Yeah.
and you have to keep stirring it.
At the very bottom, you can see it looks like it's starting to settle out, but the water is still really cloudy. I can't see through the water. So
Huh.
I wonder if we let it set for a while, do you think those other particles would settle back out?
Well, why don't we add water to the salt and we'll go back to the powder and see
Alright.
if anything happens. Sometimes time is an important factor here. Sometimes things need a little bit of time to do anything different.
Alright.
So here comes
This is the salt.
50 mLs of water. Ooh. Ooh, I want to stop for a minute just to see it.
Wow.
Huh. Right now, it's reminding me of the cloudiness of the powder, but it's not getting cloudy like the powder did. I can still see through
Definitely.
to the bottom of the cup. So I'm going to stir. And I've heard students say, oh, the water looks foggy
Yes, yes.
or fuzzy. But I'm stirring. And I'm noticing that I see a few particles of salt in the center, but,
What happened to the rest of them?
well, at this point, if this was the first time I was doing this lab, I probably wouldn't use the word dissolving. I would just notice that the salt looks like it's disappeared. I can't see it anymore. Ooh, it's clearing up.
It is, look at that.
It's kind of fun to watch.
It's almost crystal clear again.
So I can see the black paper
Yep, straight through.
through the water. And when we start talking about solutions, one of the ways to identify if something has become a solution is that it turns clear.
Yes.
You can see through it. It can be different colors, but it must be clear.
See-through, yes.
And when I compare the salt to the powder, they look very different.
Oh,
I
yeah.
cannot see the black paper
Nope.
when I look through the top of the cup. And with the salt, I can. So,
And even the
three,
gravel, yeah.
yeah, 3 materials and 3 different things happening. The gravel at no time made the water cloudy. It didn't rise up and become part of the water. It just stayed there and got darker colored because of whatever thing the water did to it. Here, the powder has not disappeared. It's settled to the bottom, and
You can definitely see the ring now. A lot clearer around there.
yeah, the water still looks a little milky, which makes me think there's some particles that might be floating in it. But wow, very different
From the salt and
from the
water.
salt and water. I guess
It's amazing.
we now have mixtures, by the way.
Yes, because we added another component. We had just rocks or gravel before, and then we added water. So 2 more things combined together. That's a mixture.
So we have 3 different mixtures.
You got it.
And part 3, our challenge is to separate all 3 mixtures using filters. So we have some tools here. Let me clear up the
Yes.
lab area. We're not going to need these things anymore.
Nope.
And
Move these out of the way.
we have a new tool, a screen. And if I were going to describe this screen, it's made of metal. Can I see that pen, Miss
Yes.
Stilson? The holes in this are big enough that they're about the size of the tip of this pen. So they're big enough for me, certainly, to see them.
Like a screen door. Whenever you have a screen door in your house, that's what it reminded me a lot of. You can certainly see through it, but it won't let the bugs into your house. Always important.
And our second kind of filter is a paper filter. And I don't know if you can see that from where you are, but when I hold it up to the light, I can see tiny little holes,
Yes.
places where more light seems to come out through it. So one difference between these two filters is the size of the holes.
Exactly. Like I can't see an individual hole, but I can in this, but I can see light through it, so I know there has to be holes in it.
Huh. So remembering our properties from part one
Yes.
of gravel, powder, and salt, I'm thinking particle size might be the important property to think about here.
I think you're right. You even think about this like a bug with a screen door.
So there's some steps there, Miss
Yes.
Stilfen. What am I supposed to do now?
All right, first step, we are going to place a screen over an empty cup, labeled cup.
I'm gonna label it using the gravel
Yes.
label. Save some paper.
Exactly. All right. And then it says to stir the mixture thoroughly.
I can do that.
And then we're going to pour the mixture through the screen filter.
Woo.
Line it up there.
I noticed that the gravel's sticking to the bottom of the cup.
Yeah.
I wouldn't have known that without doing this.
Well, I don't see it going through the filter at all.
All of the gravel has been captured by the screen. And one of the things that you'll be asked to think about is, why did this metal screen work? Don't tell me now. Write me later.
And there's absolutely nothing left in this cup.
Show the studio audience. Prove it, Miss Stilfen.
There is nothing. No gravel in that cup.
So here in this box under screen, I would write that the metal screen worked to separate the gravel from the water. Okay, what's
Alright.
next?
Well, then next we need to try that same procedure, that same step,
I just-
using the powder.
I just happen to have another screen
that.
here.
You were well prepared.
Do you
All right.
want to do this one? 'Cause
Sure.
It is important in lab groups to share, isn't it?
It
Here's a
is.
stirrer for you. We don't want to cross-contaminate.
No, no.
I'm going to get something to clean up that spill.
All right, so I'm gonna stir the mixture thoroughly before we start to pour it through the cup.
Huh.
Well,
That water looks,
that looks still the same as it
Yeah.
was in this cup, and I don't see anything caught on the filter. There's a little bit of water kind of particles stuck in there, but
so it's pretty obvious that the metal screen did not
did
work.
not work for the powder. It went right straight through.
And again, something we'd like you to think about is, why did the metal screen not work for the metal powder? What properties of the powder prevented it from being captured by the metal screen?
Exactly.
So,
Alright.
there, what's next, Miss
And then the
Stilfen?
next one is to do the same one, the same thing with the salt mixture.
Okay, let's label that. I have a different clean screen.
See? Always
If-
important.
If I was in my lab group, we'd be using one screen, but we'd be
Yes,
rinsing it in between.
You got it.
Okay, so you need a clean stirrer.
Thank you. All right. It said to stir the mixture thoroughly, so I'm going to stir it thoroughly. And let's see. Now I can't see the particles of salt in here anymore, but I wonder if the screen will catch it.
I'd be interested to find out. Whoa. I see nothing but water on this screen,
I don't see anything in the cup.
and I see nothing different
Than
than
what's in this
before we poured it. So I'm going to say that the screen didn't work.
Definitely not.
If I can't see it like I saw the gravel,
Yeah.
it's
Must
not
have
working.
worked. So again, we're going to ask you why. Why do you think it didn't work for the salt and for the powder? All right, well, now that we did the screen filter, now we're going to use the paper filter.
Do we have to use it for the gravel?
We do not, because it said, if the screen filter doesn't separate the mixture, repeat the process with a filter paper. So we were able to separate the gravel with the screen filter, so we don't have to do that with the paper filter.
Now, this is a filter stand,
Yes.
which is a pretty cool contraption. And the thing I always remind people to do Make sure you put a cup under it
Always a good idea.
before you put, do you want to model how
I
we
would
put
love
that
to,
in?
yes. Well, as you can see, our filter paper is quite large in comparison to our funnel. So what you have to do is you want to fold the filter paper in half once.
I call that, make it a taco.
Yes, making a taco.
Make it a taco.
Okay, so then you want to take and fold it in half again.
Now it's a slice of pie.
You got it. What kind of pie?
Gooseberry.
Gooseberry. All right. Now, the next important step, you have it folded just like this, is you want to make sure that you end up with 3 pieces of the filter paper on one side and one on the other. So that way, when you open it up, if I hold it up to you, there's no hole down
You
in there.
cannot see Miss
Cannot
Stilfen
see
through it.
Otherwise, it won't work. So we're going to place that in there.
And I always advise students to check, if you are looking through and you can't see the cup beneath it, you've probably put it
Fold
incorrect.
it right.
Now,
Sprinkle, sprinkle.
I want to do the sprinkle
Okay, you
if
can
you don't
sprinkle.
mind.
You
So
always
just a
wanna
few
sprinkle
drops. And that just helps the water go through more quickly.
Exactly. And I know some of you may have seen these filter papers before. If your parents drink coffee, you may see those quite often, and they are similar shapes and work kind of the same way. All right, so we want to do powder first?
Yes.
All right, so stir, stir, stir.
Even though this didn't have a label, I knew it was powder
Yes.
because it looked so different than the gravel and the salt. So I want to stir this really well because I noticed one thing that the powder seems to do is to sink to the bottom. And if I don't stir it well, then it won't travel with the water as I pour this. So here we go. This is like a magic trick. You put in cloudy water and ta-da! Let me turn the label so people-
Wow. And
It's
the clear
clear.
water comes through.
And I'm noticing that there's white powder sticking to the sides of the paper filter.
Let me just bring this over so our audience can see that as well. So if you can see, there is powder stuck to the sides of the filter paper.
I'm going to put my reputation on the line, Miss Stilfen, and say, I think the paper filter worked. with the
I think
powder.
it definitely worked for the powder. I agree. I would stake my reputation on that as well.
And what's kind of neat is there's this beautiful little pattern that's formed. I'm going to bring that up for people to see.
Yes.
Because if you didn't have a chance to do this lab, you missed out. I don't know if you can see white on white very well, but there you go. And I'm going to spread this out.
Can you grab a paper towel?
Well, I'm going to put
You're
it
gonna use
right
only wet
on
paper?
the cardboard paper.
All right,
And
wonderful.
I'm going to bring that up so you can see this
Oh, yeah.
lovely white pattern.
Look at
And
that.
I'm thinking it captured all of the powder because that's looking pretty clear to me.
Me as well.
All right, I'm going to
Okay.
rinse
Rinse
the
funnel.
filter stand.
Good. I will start to get our other filter paper ready, because now we have to do the exact same thing with the salt and water.
And I'm really glad that I'm doing this with a partner because this is a lot of steps. And the benefit of a lab group is that you get to share the work.
Yes.
So here's my clean cup. And where's my salt? Here it is.
I moved it. All right.
Label it.
So I'm gonna put the filter paper in there.
I'm gonna bring this salt and
Yes.
water
Sprinkle.
solution up for you to look at. It's clear. So I'm thinking, how are we gonna know if it worked? The powder in the water wasn't clear. Maybe we'll see it on,
Maybe
The
it'll be on this
filter.
paper.
okay, where's my stirrer?
It's in that cup there.
Okay. So I'm stirring.
Right.
There really isn't anything for me to pick up at the bottom like there was with the powder.
No, I don't see any salt crystals in there anywhere.
Sprinkle, I can see that. Here we go. Well, the water is certainly traveling through.
Now Now, something that I noticed is that this is traveling a lot faster through the filter paper than the powder was.
Huh, I wonder why that is. It's a really good observation.
It's all the way through.
It's a funny sound.
It is drip, drip, drip. Leaky faucet.
All right, this is tougher because the water was clear to begin with.
And it's still clear. I don't see anything in there, do you?
No, but I didn't see anything in there before.
Hmm.
I'm gonna open up the filter and put it on this black paper and see if we can see anything.
White crystals.
All I'm seeing is water. When I compare that to the other one, powder one, I can't see anything besides water.
Yeah.
Powder I can tell worked. So now we are left with a
How do we do this now? Well,
I can't put my scientific seal of approval on this paper filter. I can't for sure know that this paper filter
Right.
worked.
For separating the salt.
Right, because I know that the metal screen worked for the gravel.
Yep.
I know the paper filter worked for the powder. I'm not sure, and I'm not going to taste this because it's unsafe science for me to do
Yes.
that. I can't see it. I don't know. So I'm going to suggest that we leave this for a few days and see what happens.
All right.
Now, through the magic of movie making,
Time-lapsing.
I just happen to have 2 dishes here that had salt and water solution put in them.
Get up close so you can see.
And I'm going to dump one of them out on the tabletop.
wow.
I'm looking at the sizes of this. Oh,
Look at
there's
the shapes.
there's one lovely crystal here that I want to point out.
It's like a square.
Yeah. So I now can see that there was salt left over.
Most definitely.
We use the power of evaporation, which is when water goes from being a liquid to turning into water vapor, which is a gas, becoming part of the air. And the water was able to make that change to a gas. The salt was not. The salt got left behind and is a solid again. And it's in a much larger size than it was when it was dissolved in the water. And now I know for sure that it's been separated. I had to use a different kind of filter or process for each of my 3 materials in order to separate them from water. They were all mixtures, and all of them were able to be separated from the water. But we had to use different ways.
Yep.
So there are going to be some questions for you to answer after you watch this, and it will be part of the web page. And any experiment that's worth its salt, should give you some questions, some new things to wonder about. And so our challenge to you is, what does this make you wonder about gravel, powder, or salt? What does it make you wonder about mixtures? What does it make you wonder about separating mixtures? Is that it for today?
I think that's it for today.